and looks like we are live. Okay, great. So start in Hebrew. חברים, וובינר מוצר השבוע. השבוע אנחנו נציג מוצר שנקרא Corezoid. החבר'ה פה מאוקראינה, אנחנו נדבר באנגלית. אם יש למישהו שאלות והוא רוצה שנתרגם מעברית לאנגלית, תרגישו חופשי לכתוב או בפייסבוק או תצטרפו אלינו לזום. And now I will move on to English. So we have the people from Corezoid with us, which is a really interesting product. I think is very relevant for all of you guys. And I will actually let them do whatever they want for an hour and use the group as a platform to kind of present their product. And I guess it's time to take it from here. So Olga, would you like to start?
Yes, super. Okay. Hi, everyone.
First, you should do introductions, like who you are, your position, so people know who you are.
Good. Hi, everyone. Ayala, thank you for the invitation. We are glad to have the opportunity to present ourselves and our technology Corezoid as well as the best case studies. Let me introduce participants briefly from our side. I'm Olga Hudik. I'm responsible for business development at Middleware, and I'm managing a couple of huge projects that will mention during the session. My colleague, Karina Chibunina, Chief Payment Technologies, Alex Zinchenko, Tech Lead and Product Owner for Corezoid, and Rita is our business analyst. She joined us from Canada. Rita, thanks for being with us today. Let's review the agenda for today's session. The first one about middleware, what is Corezoid, case studies, Corezoid demo, and some question session. After the session, I will be happy to help with development of any cases. If you have any questions, please don't hesitate to contact me after the session. Thank you so much. Karina, please go ahead.
Okay. Now let's talk about middleware. We are not a classic startup or IT company. We are considered to be technology partner for our clients just because we provide not only software, but we also provide our ready-to-use products, our expertise and vision. Our CEO and the team has 24 years of experience in fintech and 20 patented technologies. Our 4 proprietary technologies are the main ones on the screen: Corezoid, Sender, Deep Memo, and Control Events. But today we're going to focus, of course, on Corezoid. On top of the proprietary technology layer, we built a lot of products focused on fintech, payments, communication, banking, etc., all for our clients in order to provide ready-to-use products and connect quickly. So what is Corezoid? It's not a single word or not a single term that you can quickly describe, but we say that Corezoid is low-code, no-code system, which is digital core for any company that combines it all: state machine, APIs layer, automatic programming, BPM, CRM, etc. When we usually talk about Corezoid, we draw the analogy that common development cycle is a lottery, because you never know what's the outcome of the development, when it's going to arrive to you, when it's going to be fixed, debugged, refined, etc. And eventually, how many resources you're going to need to maintain that code, to review that code. But Corezoid, by having it all under the hood, allows you to build and connect all the dots inside the company, all the APIs, all the services, really transparently, really flexibly, without involving extra IT resources, just having the business analyst managing all the logic. Because usually the company has this legacy software layer, which is connected very hard, because each and every legacy software has its own protocol, and there is also human factor in the middle. But Corezoid is serving as the orchestrator in the company, connecting all the dots without the need to replace any system. And also, Corezoid allows to separate business analysts from the real IT. Usually, the standard development cycle is when business analysts create the change request and waits in a queue for that development to be completed. Then it's an iteration which needs to be refined, debugged, tested, recreated, etc. So it's an endless queue, basically. But Corezoid allows to separate that and make that process parallel, because IT only should be responsible for APIs and SLAs, and business analysts can consume those APIs in Corezoid, build business logic of any sophistication inside the Corezoid. And by that, removing all those stumble blocks, Corezoid allows also to increase economics of the company by 10 times. Also, we are really focused on involving and enhancing Corezoid features by constantly adding new ones. And one of the recent ones are GitHub integration into Corezoid. We created that specific node, which Alex is going to present you during the session today, that is called Git Call. And it allows to connect any project from the GitHub into Corezoid without any extra layer in between. The same goes to DB call node, which allows to connect any DB without any API layer between Corezoid and actual DB. So now let's talk about use cases and clients. We work with a variety of clients from different sectors: banking, fintech, retail, payment systems, insurances, etc. For all of them, we either provide Corezoid with vision, expertise, or ready-to-use solutions that we've already built. Also, middleware is the certified partner at different companies such as Apple, Google for messaging, also Rakuten, Viber for messaging. We're also strategic partners for Visa and MasterCard payment systems. And our products are presented on Amazon Marketplace, and we're certified by AWS. Having that many years of experience, we've presented a lot of our innovations and technologies on the world stages, such as Money 2020, Finovate, etc. One of the recent examples is Share Credit Card, which is the product built on top of Corezoid. And it's a disruptive for payments because Share Credit Card, on the contrary, do not do money transfer from person to person or card to card. It allows to share access to a card with the use of token. Also, Chris Skinner, our good friend, mentioned Corezoid disruptive impact on banking in his books. One of the interesting cases that we built for our client, Western Union, is the digital platform that allows to do money transfers in all those 46 countries that are now live because of the Corezoid and with the help of Corezoid. We built the platform 3 years ago and now launched all those countries. And by templating each and every country and adjusting only the variables such as KYC or amounts, we've gained a tremendous speed and allowed Western Union to launch all those countries. Besides the backend platform, we're also developing VU.com website and mobile apps. Mambu, it's a core banking company in Europe, and our dear friend Ben Golding, who is CTO at Mambu, they are using Corezoid as a white label solution in order to create connectors and connect core Mambu banking solutions to legacy software of the banks. Right now, we have 40 plus partners, 40 plus banks connected to Mambu Process Orchestrator, basically white label Corezoid on Mambu. Another interesting case, which we have built and already launched in Azerbaijan with Unibank, is a digital core for neobanks. We created this product as a ready-to-use solution for any neobank that wants to launch not only backend platform, but also interfaces such as iOS and Android mobile apps. So we've launched the first bank, Unibank. The project timeline was only 6 months from the scratch to connect the backend to the legacy, to the processing center of the bank, and then launch the neobank from the scratch. During the first months of the launch, they've issued actually 56,000 cards. Then Glovo. For Glovo, we created with Corezoid the supply management system. It's actually an integration layer also that allows to connect quickly any supplier into the Glovo app, supply of goods, services, etc. Right now, we have 4 countries live with 58 suppliers connected into this integration layer. For Metro Cash and Carry in 3 CIS countries, we created also digital core using Corezoid and interfaces such as messenger boards. For Metro, we disrupted the way how they now work and onboard their clients. They actually now do the online onboarding inside the messengers, and the Corezoid allows them to onboard client, to provide the loyalty, to provide the communication, and also enable digital card issuance. They now issue 1,000 cards daily. Philip Morris. For Philip Morris, we also created a single core that enables order lifecycle management, client lifecycle management, device management, etc. All the communication, all the registration, onboarding, and e-commerce goes through the Corezoid platform using the interfaces messenger boards. Right now, with Philip Morris, we've built the solution and scaled it for 16 countries. Blue Finance, it's a Nordic company that issues loans. For Blue Finance, we created the platform that connects local APIs for eKYC, money transfers across Europe in order to provide loan services to clients. Now we've launched 2 countries, the 3rd country on the go, and the project timelines is 1 country during the month. So it's a tremendous speed for such a company to launch inside the Europe financial services. We also have a huge experience working with governmental sector in Ukraine. For Ukrainian governmental departments, we've built various solutions for communication with citizens and also ticketing, such as, for instance, Ukrainian railways. And in terms of communication, we have already the ready-to-use product, which is Cloud CRM, which contains all the business logic, all the communication templates that only needs the company's APIs in order to start communicating with the clients. And here's how Corezoid can track the states of the customers using the specific nodes, which Alex is gonna demo later. So now we are ready to demo Corezoid. Maybe any questions at this point? Okay, now back to you, Alex.
So far, anybody? Sorry. Anybody say something? Was me or my echo in your speaker? So that's great. We can go into the demo. No questions so far. If there'll be any questions, I'll just let you know.
Okay, guys. So let me share my screen. And we'll start. So let's start from the very beginning. Here is our marketing website, Corezoid.com. Here you can find all the information about our company and our product. And here is the button that will guide you into our user interface. This part of the user interface is called file editor. So here you can manage your entities, plug them into the folders, and so on. So let's have a look. What actually do we have here? So on the workspace tab, we can create projects, or we can create processes, state diagrams, dashboards, folders, what platform, database, or load all the stuff from your file that you uploaded recently. On the activity monitor tab, you can monitor the activity of your processes inside your account. You can pick up some date range that you need and look for statistics. On the user and group section, you can manage your colleagues that will develop with you, your integrations, manage your API keys that you will attach to your processes, and provide this credential to some other companies that will load that data to your processes. On the aliases folder tab, you can create the symlinks to the processes in order to keep the same references whenever you decide to unlink this reference to another process. So let's start from the processes itself. So let's create a process. The only thing that you should do is hit the create button, pick up the process, choose the name, the description, and that's all. Once process is created, it's ready actually for receiving the data. But let's discuss what you can assemble here. On the left panel, you have a list of smart nodes that can be used for assembling your algorithm. This set of nodes allows you to create any kind of algorithm with any kind of complexity. And please remember that your project, your automation development can consist from a lot of processes, and they can communicate together. It's very important. So you can decouple some logic. For instance, if you are familiar with programming languages, while you're programming, you're creating some modules, some functions in order to decouple your code and make it readable. The same idea is in Corezoid. So you can create separate processes for some domain areas, and then link them together and create some big algorithm.
Quick question, just sorry to stop you.
Yes, sure.
I'm wondering, so what you're saying is basically that you can create these processes and they can be interconnected according to some external logic, right?
Yes, but not external and internal too. So we have the possibility to call the process from another process. For this purpose, we have call process node. So here you can choose which process you want to call and specify what parameters you should send there. On the other hand, the process that will be called will use the reply to process. And here you will specify all the keys that you want to return back. Further, I will show some simple example with the two processes, and I will show you how they interact with each other. Yeah, but let's go deeply, briefly across the nodes. So here we have condition. It's a basic node that allows you to manage the route of the execution based on some condition. Equals, not equals, more or less, or regular expression. It will work like this. So if parameter A equals 1, then the execution will be navigated here, else here. Here we have code node. You can pick up JavaScript and Erlang. Why Erlang? Because our backend is written on Erlang, and we believe that it's very fast and scalable programming language that allows us to hold the high load. So you can write some kind of script here that will manipulate with the data that is traveling across the process. And if you want to reach out the data that is passed to the process, you have this data global object in the global visibility area. So data A equals 1, that means that in the task that is traveling across the process, field A will become equals 1. Here we have copy task node that allows you to copy the task from this process to another. So it's like a fork join pattern in the programming languages. You can fork the execution to another process. And this is sum node. You can summarize some parameters that are traveling across your algorithm and show the sum on your dashboard. I will show later what it is. This is modification of the task that is already exists in another process and waits for modification. This is delay, so you can delay an execution for some limit of seconds.
What's the limit? Can you delay it by a week, or is that not possible?
It's possible.
So it's not limited by any time, or?
The minimum amount of time is limited, but I think they're not maximum.
Okay, somebody asked a question. Where does the data reside? Customer VPC, and what are your certifications in terms of like security? You can answer later if you want. If you want to finish this, show the system first.
Yeah, let's come back to this question.
Okay,
later.
basically, we provide Corezoid to customers' environment, which may be AWS, in-house, on-premise, any other client, cloud like Azure, etc. So all the data that is being processed by Corezoid, so Corezoid doesn't store any data, it's being processed by, it goes specifically inside the customer's environment. So the customer's privacy policy, security policy are covering this part. In terms of certification, our company has ISO 27001.
Okay, I will proceed. So the most relevant node is an API call node. So here you can specify the URL and all the parameters of the API query and fetch some data from your microservice or send the data to this microservice. There is a lot of options that you can choose. So actually any kind of a HTTP response is handled. Also, as Karina mentioned, we have some fresh nodes that allows you to execute the code that is stored inside of the Git repository. I will later show how it works. So that means that you can manage your code base for some special things somewhere out there in the Git.
Let me get it straight.
GitLab.
I'm sorry to cut you off. I just want to make, this is a really important point. So basically you can have all your custom code in a specific repo and have it managed through there, including versioning and everything.
Yes.
That's amazing. And so, and that basically you just read the code and run it on your server, right?
Yes, we have a set of languages that we are supporting right now. You should follow some simple rules how this code should be structured. For example, for JavaScript, it should be wrapped into some module that will return this model. And then you just specify the repository URL, the branch or a commit that should be referenced, build it, and that's all.
Great, great.
Yeah, also we have a possibility to make a database query. In order to do this, you should create the database here. So you just fill up all the fields and provide information for managing the connection.
So you create databases on Corezoid?
No. You just
the connection.
You should create, yes, just the credentials. Yeah.
Okay. And is there any like I'm just wondering, like, because sometimes there's some sort of like issues with connecting to databases from external IPs. It's an issue, right? So it's either, so you said it's either hosted on Amazon or on a self-hosted solution?
Yes.
And so regardless, you need just to whitelist that specific IP, right? So that will be possible whether it's AWS or, okay, got it.
Yeah. Once database connection is created, you can choose this instance. Choose this instance and make a query, actually. I will show later the example. Sometimes your task that is traveling across the process can wait for some callback, and this will be done by modify task from another process. So you can hold up an execution and proceed it from another process, trigger this execution further once you are ready.
So until you get a callback, it doesn't continue to the next step, basically.
Yes, it will wait. It will wait.
Even if it's, once again, it's a really important point because we have a lot of Zapier, Integromat, and other systems similar to that. So basically, you can wait for a callback for a month. You can hold up a process for a month. You can go like as long as you want, or is it limited by some certain time frame?
It's not limited.
It's not limited. I'm just wondering if you can do like things that have to do, because the one point I realize that's different in Corezoid is that there's different stages, right? So it's like stages of a process that have different processes within those stages, right? Like the whole logic is that you could delay something for a week, which is not possible, for instance, in Integromat. You can't just say this process delay the next module's execution for a week. You have to separate into a different module and into a different scenario. So here the logic is completely unlimited, if I'm not mistaken, right? Okay.
Okay, so here we have a few nodes that allows you to communicate with our own chat that is called Sender. You can send forms here or send some actions here. I will not stop here because we are concentrated on Corezoid product. You can create queues and read from queues. So, for instance, one process can accumulate the task in the queue node, and another process can use the get from queue node and get in one by one the task from another queue.
What could be the usage for this? For instance, for like I'm just imagining a queue as like I have salespersons and there's leads coming in, and there's a queue of salespersons, and I just like get a different salesperson each time. That's like an example for a queue?
Yes.
Good. Okay.
Also, you can change the task that is traveling across the process with the set parameter node. So here you can specify which key, what value will hold. Also, this can be done, as I said earlier, in the code node. So you can use some code snippet in order to interact with your data inside the task. And the last nodes, these are archives nodes. So final and final node error and success. So the key point that once task reaches the final node, we will just keep the counter, how many tasks were there. And after some period of time, the data will be erased because Corezoid do not stores your data in the archive nodes. So the data will be available for some period of time and then will be erased. But at the other hand, if you use queue nodes, if you use waiting for callback nodes, the task will sit there and wait wherever you want, then wait. Okay, so what do we else have here? We have not only the edit mode, we have view mode. Here we can, let me share another example. We will go step by step for each logic. Okay, so here is the view mode. Here we can watch online how our process is living. So once task will be sent there, we have this panel for testing purposes. So you can upload testing data with this panel and watch online how it travels across the nodes. Also, you are available to look through the data that is situated right now inside the node. You can upload this data, download this data to CSV file. You can look through statistics with some date range. You can look it online. So here is how it happens. As you can see, we have some activity here. What else do we have? We can import the data from CSV file. For example, you have a Google spreadsheet with your customers, and you assemble the process that will communicate with these customers via SMS. So you can extract the data from your Google spreadsheet and as a CSV file and import here. And all this data will be uploaded to your process. So every line in your CSV file will be a separate task.
So basically, you can do this from CSV, but can it be done via Google Sheets, or that will require some API connection?
This will require the integrational process that will interact with the Google spreadsheets and extract the data here. Okay. But for some purposes, customer uses the custom CSV files and upload this data by hands. Also, you can use a webhook for sending the data to the Corezoid process.
Okay, so you can actually use some sort of API to send the data via HTTP request.
Yes, sure. So, this can be done via webhook, and this can be done via creating an API key here in the users and group section. Every API key has its own login and secret, and you can give these credentials to some other microservice, and it will use our API in order to sign the request and send it securely to Corezoid. Okay, so briefly, this is it. And I have been prepared some sophisticated examples for each logic. And my suggestion to go one by one and look how it works live.
Sure.
If you have any questions on this point, please ask.
I have a couple of questions. I mean, I don't know if a couple, maybe one, but is there some sort of execution timeout limit in any way, or can a process run for 4 hours?
Process can run forever. You can have an infinite loop inside the process if you want.
Yeah. Okay. That's what I mean. I'm just trying to get kind of a grasp of the differences between the systems we know in Corezoid. So there's no execution. For instance, if I have to call an API and I have to make 4,000 calls to get all the different items using some sort of pagination, that will never crash, right? It'll just keep going until it stops, unless there's an error, of course.
I believe that's right. I believe that's exactly right.
Great. Thanks.
Okay, so let's start from the DB call. So I prepared the connection to our internal database. Here it is. So I've got this entity here available, and I've created the process that will fetch the data from the database. So in order to launch the process, I should send the task here. So at my example, no input parameters was specified for the task, so it will be empty. And when task will travel through the database call, the query will be executed. And once it will be executed, all the data from this query will be added to the task. So here it is. So as you can see in the special field, DB call result, we have the array of items, array of users. And I can assemble some logic further that will go through this list and do something. So here is a database call. In the edit mode of this node, we can specify the SQL and pick up the connection that we want to use. Okay, the next logic is Git call. So Git Call. In order to use Git Call, I will create some simple repository. This repository is written on JavaScript, and it consists from the one file. And the logic here is to fetch this API with the help of HTTPS library from NPM.
This is important. It's not JavaScript, it's Node essentially, right?
Yes. No,
so whatever you include, whatever you require will be automatically installed. Okay.
Yes, you're right, yeah. So in order to make this work, I should wrap it into the module exports function. And the input parameter will be the data of the task that is traveling across the node. And here, after HTTP request is done, I will add the field to this data with the body of the response from this third party. So no extra code is needed, just repo URL and the branch that will be used. Let's deploy it and look how it works. When the first task is sent to Git Call node, it should prepare the internal mechanism, and we will have the cold start effect. So it will take some time for the first request, but then it will be warm and everything will happen much faster, as you can see. And let's have a look what it is. So this API responded with the array of users, I think. Here it is. So we can manage.
Reiterate here because not everybody's a coder on this group. Let me just explain what they're looking at. So what you're demonstrating is you're managing the whole code through a GitHub repository. And you've written some Node.js code that will make a request to an external API, and you will return the results to Corezoid. So nothing is basically written inside Corezoid. You write all the code from in GitHub, you manage it through there, and you use that to use Corezoid to run the code. So if you can see the data in here, so there's data. Data is a global object, which means it's what the data that Corezoid is reading from. So once he adds more data, adds another key into data, you can see the result on the debugging console, right?
Yes. So it allows us to reuse some coded snippet that already have been created somewhere, yes, or we can delegate the responsibility for this functionality to the programmer that is more has no knowledge in this specific area and so on. And we will just focus on the logic. So give me my data and I will do the rest. Yeah, this is how it works. Okay, so the next example is task modification. So here I have two processes. One is waiting for callback. Let me do like this. So on the right side, I have the process that have this waiting for callback node. And as you can see, the counter of the task is 3. So that means that I have 3 tasks, here they are, that are waiting for callback. So they aren't moving anywhere, they just sitting and waiting when the modification will happen. Every task have the special field that is called reference. So this field can be set by the user when you create the task here or via HTTP call. And this is a unique field that will allows you to reference this task in your logic. So I will copy this reference and switch to another process that is responsible for modification. So in order to modify the task that is waiting for callback, I should use modify task node. I've already prepared this node, so it will use the process from the right side of the screen. It will transfer the reference from the task from this parameter that I already specified in the separate window. And let's just have a look how this works. So new task, reference, add task. As you can see, modification have just happened and the modified task moved further. So we have only 2 tasks left here. And here is the result of the modification.
So basically,
so
you have one process that's, for instance, generating some sort of process, and then it has to wait for some sort of callback from an external process until it has to keep running. So you're calling that specific run from a different scenario, from a different process. And I'm trying to think about like use cases here. There's a ton, right? So like approval process, right? So until like 3 people approve the process, only then you can call that process and make it work. And so it's really useful.
Yes, yes.
What's the difference between waiting for a callback and
manual task?
Sorry?
Yes. Some manual step, for example, is required.
Yeah.
Someone has to fill up the form and push the button, I'm ready. And then the process will modify the data and it will move through further through your funnel.
What's the main difference between waiting for a callback and a queue, basically? So queue, just you load things into a queue?
Yes, you cannot read from the waiting for callback. You can just modify it. The data.
Got it.
So
okay, so let's move.
The question about this, but waiting for a callback, any limitations, any timeouts, any limitation on how long the callback can wait for the response? And also, can it accept, the process can accept other requests coming in meanwhile on another task that's waiting for a different callback?
You're muted, Alexei.
Yes. Can you repeat the question and speak louder, please?
Yeah, sure.
Ray, your microphone is really low.
Sorry, my mic is kind of bad. Yeah. I was asking, is there any limitation on the queue? Like, I mean, so we said it's meant basically for manual processes that need to be approved or something like that. Is there any time period that queue will time out? I mean, can it wait for 40 minutes, 2 hours, 4 hours? And my second question is, meanwhile that queue on that process is waiting, can other tasks come in and complete? Is it, can it accept one like process at a time or multiple at one time?
Multiple. So you can have a lot of tasks that is queued. Every task have unique reference, and actually all the tasks you can reference with this reference, and they can wait until you need it. But the limitation that protects the system, that we have the maximum size of the task that can be transferred to the Corezoid. For our Corezoid.com, it's set for 512 kilobytes, I think. And for in-house on-premises hosting, it's up to user. But the main idea that you should not transfer a big amount of data through the processes.
So your concern is not time, it's the data.
Excuse me, can you repeat?
So the concern when performing a process that has a queue, the concern is the amount of data you're transferring, and you shouldn't worry about the time it takes to complete it.
Yes, you shouldn't worry. Yeah. Let's, by the way, go through the queue and look how it works. So here we have two processes, the queue and the get from queue. So let's switch to view mode. So let's queue, put some task in the queue. So I'm just adding some random data. And all this data is stored right now here and waiting. And here is the get from queue logic. And in order to make it work, so I referenced the process on the left-hand side. I referenced the node of the left-hand side. So here it is. The process is here, the node is here. So it was picked up with this editor. And let's go here and send the task. As you can see, I'm receiving the task from the queue. Here they are. And this task have this data, actually, what that was stored there. Okay, the next example is call process. So on the left side, we will have process that will call the process from the right side. The right-hand process will provide some basic calculation. It will summarize few parameters and return them as a result. Simple calculator. So I can decouple the logic to another process and use it like a function. So here is my parameters, A, B equals 1 equals 2. I'll send task here. As you can see, task was executed. Here is the result, and the result was passed to the call process, and here is the result.
So you're sending a call to a process, and that process replies with the result. So you can do a different process. I get it. Okay, so connecting two processes together, essentially.
Yes.
Okay.
Another example is copy task. So I can copy task from one process to another. So here is process from, here is process to, and I will copy this data to another process. And let's switch to edit mode, to view mode, sorry. So here it is. As you can see, the execution continues. It doesn't stop here, but the task was copied here as well. So I can
just one
branch the logic.
Like what does a task qualify as? Like, is it a run? What is it exactly?
I didn't get your question.
I said, what is a task exactly in your terminology? Is it a task?
In our terminology, it's the payload of the HTTP response that you specified while sending the data to Corezoid. In this case, it's just a JSON object.
Got it. Got it.
Yeah. And here it is. So I've specified this payload here, and got it here. So I should speed up. What else do we have? Let's go briefly to state diagrams. So you can create not only processes, but then state diagrams as well. This is can be used like a simple storage that can be referenced. So here I have a state diagram that consists from one node, and it just holds the data. It doesn't move it anywhere. And as you can see, I have one task here, and here is the payload of this task.
Can you explain more about the states? This is really interesting for me. What would qualify as a state? Give me like an example of several stages, states, or that use processes like this.
I will explain a little bit earlier after this use case. Okay. So here is the process that will read the data from this state diagram. You should use this special construction that will reference a specific process with and specific reference of the task inside of this process. And so I can store some configuration there for my internal needs. So here I'll just read this information. So you ask about the states, and let me share the different use case with the state diagrams. This is use case from our real client, Metro Cash and Carry. And we used in this use case the state diagram for describing the customer life cycle. So we determine the states for this customer. So for instance, his first visit and 2 weeks, there wasn't no visit, and so on and so on. So we define the rules of traveling from states to states, and what logic should be triggered when something happens, when state is changing. And as you can see, it can act like a real dashboard with the real counters. So here we can see the real picture, how many users we have in our chatbot, or I don't know what is the front end for this application. But anyway, we can see the real numbers. We understand which are the explicit states of our customers and what logic will be triggered when the state will be changed.
Let me just say that is insane what you're just showing right now. It's like literally insanity.
Yeah, and it's real. As you can see, it's alive. So something happens, states are changing, some processes are triggered, and so on.
So states in your example is a life cycle of a client. So if it's the first visit, there's a process. For the week later, if there was no set actions done, then there's a different state, right? And you trigger the states from different processes, if I'm getting it correctly, right?
Yes, I've just described the states, described the rules of transition between the states, and I have a bunch of processes that I'm manipulating with the state diagrams. And when user transitions from one state to another, some process is triggered as well.
Yeah.
So, for example, we should communicate with our client, we should send him an email, and etc.
And we're looking at this live. So basically, once it runs, we can see whatever happens live.
Yes, it's live.
That's
a real client. Okay, guys. So I think this is it. I will wrap up because we have only 5 minutes left, and we have our colleagues that also wants to present his use case that he managed with Corezoid. Sure. So if you will have any further technical questions, please find me in LinkedIn. You will have my email, or you can go to corezoid.com and contact our support. So thank you very much for attention. Julio, the stage is yours.
Before Julio speaks, we suggest maybe we should have another technical session to dive more into Corezoid, because there are definitely more to it, more use cases that we didn't cover, of course, and more variety of the business logic that can be built with those nodes.
Of course, this can be done in an hour, right? This is just an
yes, for sure. We only had like 40 minutes about, so let's talk offline about the next.
Okay, we can do it even 5 minutes longer. It's okay. I'll let whoever wants to present whatever he needs. Good. But just one thing, I mean, I want guys to sign up to Corezoid and start using it, right? So we're trying to get some users. Once they're you see there's like a nice number of users on Corezoid, let's definitely do another session and have them kind of participate and really hands-on achieve things in Corezoid, because I'm really impressed. It's kind of blowing my mind, but it's a new thing that I have to learn, and that's what I probably think that other people are thinking the same. But yeah, definitely we need to see more use cases. It'll kind of make us understand on how this platform can be used.
Okay, sure. I'm thinking also we could, invite Corezoid developers that can give definitely more technical knowledge about Corezoid during the next sessions. Okay.
Sure. You're always invited. So who was the one that wanted to present a use case? Was there another one? You said Julio?
Julio is not with us. I think he's sick, so he can join.
Okay, too bad. Well, we'll probably do that next time. If you have any questions, anybody, like you said, feel free to contact them. The way this thing happened is by me opening an account and getting an email from Corezoid, and I said, hey, I have a group. Would you guys like to do a live? That's how it happened. Like literally 2 emails and 20 minutes later. So they're very responsive, and I'm sure they'll be happy to help you guys and answer your questions.
Okay, another quick thing I'm going to show very quick is about templates. So when we mentioned that Corezoid can give you the possibility to assemble business logic from the scratch, right, of any complexity, etc., it also allows you to template the solution that you've already assembled in Corezoid. Let's say you have similar clients that you want to provide the same product, the same solution to. So in order not to create from scratch in each and every time let's say, just as an example here on my screen, P2P card-to-card money transfers using Visa push payments API. We created this template for the banks because from our experience, the bank cannot assemble very quickly that process, especially when the bank has different interfaces such as mobile app, website, kiosk, etc. It takes about 6 months, you can imagine, to build the process, the business logic that includes all the variables, all the inputs from different channels inside this P2P card-to-card money transfer process. So we created this tree-like structure of the folder, which we distribute to our clients currently, which has just the core process as a one line that describes what is happening under the hood inside the tree of processes. So the logic is this, right? The preparation, the account validation, the screening of different anti-fraud, whitelist, watchlist APIs, etc., and then pool funds API call node, which also goes down into another process, which actually calls the different APIs, MasterCard or Visa with the API call nodes. And then after the pool fund successful, we go to push funds. And finally, when the process is complete, we have different nodes that actually, distributes the different tasks, different states into different diagrams. So this is as an example how, one can assemble a product and then distribute it to multiple similar clients.
Just to be kind of clear here, I don't know if people understand, but you're basically telling me that even like a mobile app or a SaaS could be run by Corezoid, right? Like the backend, all the processing, all the backend processing, all the code, all the data manipulation, anything that can be achieved by essentially developing using code and traditional methods can be applied and used by Corezoid. Right?
Yes, absolutely.
And you're leading by example by doing it.
Yes.
Great. That's amazing. That's really amazing. My only comment to you guys is that like more templates, more use cases will be great, step by step, and people will be glad to kind of use the system when it's possible. But I'm certainly gonna try and kind of learn how to use it better, and others as well. We have some really some power users with us in this webinar right now that will probably kind of start using it once we finish this webinar. So I want to thank you guys. Like, thank you so much for being so responsive. And it took us like a week to set this up. And you guys are invited whenever. And once we get some more users, definitely come back and we'll do a more technical and more kind of step-by-step tutorial, so to speak, session, if you guys are interested.
Nice. Good.
Great. So thanks, guys. Hope to see you guys again, and have a great upcoming weekend.
Thank you, everyone, for being with us today. Have a good rest of the day, whenever you are.
Thank you.
Bye. Thanks, guys.
Bye.